Recall from the last course project exercise the output function, the function that we use to print all the CD details out to the screen. How many parameters did that function take? Well, it took several, including, of course, the title, the artist, whether it was an album or a single, the price, etc., etc. Now imagine if we wanted to track a much larger number of pieces of information about any given CD. Imagine if we wanted to track 20 different pieces of information about each CD. What would that do to our output function? Well, clearly, we'd have to provide about 20 parameters to the function. Now, that's obviously not a very nice way of doing things. That can get to be quite a lot of typing, can get to be quite unwieldy. There's got to be a better way, and there is. What we would do instead is we would create a structure called a CD. Now I'm going to have to explain what that means. So let's use another example. Let's suppose we wanted to track all the employees in our company. So we wanted to that we could use to store the details of one employee. The question is, what data type would that variable be? Would it be an integer, or a float, or a string? Doesn't really seem like it could be any of those. What sort of information would we need to track about an employee? Well, we'd obviously need to track their name, which would probably be a string, and their age, which would be probably an integer, then their salary, which might be a float, then their sex or gender, perhaps their home address, their email address, and other bits and pieces. Now, what if it were possible to create a data type that we could use to store the details of one employee? Rather than being forced to cram all that data into one integer or one string, which might perhaps just be possible with some clever coding, imagine if we had the luxury of creating a data type, a brand new data type, one that we've defined ourselves, so we're not limited to ints and strings and floats anymore, that we could use to store an arbitrary amount of data. Well, that's where structures come in. That's what a structure is. It's a brand new data type that we create ourselves. So let's look at how we go about creating ourselves a structure. What we're doing here, I want to stress, is we are inventing a brand new data type to go along with the ints and floats and strings and so forth that we had already. This is something that you only have to do once per program. You only have to create the new type once. After that, you can use it just as you might use int or float. You can use the new type to create as many variables as you like. Now, you need to know that a structure is a composite type. In other words, it's a type constructed of other types. In other words, you build a structure from component elements, such as integers, strings, floats, and so on. You can even use other structures as elements of your structure, if you've already got those other structures created. This structure must be defined before it can be used. Like I said, you define your structure at the beginning of your code, at the beginning of your program, and then you can use it to declare as many variables as you like of that type. Let's see what one looks like. Well, we use the keyword struct, and then we specify the name of the structure that we're trying to create. Then we use the open curly brackets, just as if we were creating a function, but we're not creating a function. Notice there are no parentheses after the word employee. Then inside the curly brackets, we put all of the fields of the structure. We call them fields of the structure. They're, if you like, they're like little local variables, but you can think of them as the components of the structure. We can say that each employee in this example has a name, and each employee has an address, and each employee has an age, and so on. Finally, when we've written down all of the fields, all of the elements of the structure that we wish to create, we put the closing curly bracket followed by a semicolon. When we've done that, the creation of the definition of the structure is complete, and we can now go about using that new type that we have created. So how might we use it? Well, we can use it to create local variables or global variables or any type of variable we like. We can use this structure as a function parameter, We can even use it as a function return type. In fact, we can use it anywhere that we use an ordinary type. Anywhere you see the word integer, you could replace it with struct employee. Let's have a look at how that might look. Structures are used just like other variables, and this is how you go about declaring a variable to be of type structure. You would say struct employee, and then the name of the variable that you want to create, say emp1, emp2, would create us two new employees called emp1 and emp2. Now, if you replace the words struct employee there with the word integer, or just the word int, I'm sorry, then you would be creating two variables, emp1 and emp2, which would both be integers. But now we're doing exactly the same thing, except instead of creating integers, we're creating employees. And you can assign one to the other as you might expect. If you want to access the individual fields of the structure, you do that by using the dot operator, and this is how it looks. You might say emp1.age equals 34. Remember that age is one of the fields of the structure that you created earlier. So let's go and have a look now at some code example for that. Okay, here we are in struct.c, and I've created a structure right here at the top of the program, pretty much just as I explained it in the introduction to this chapter. So now I will go about using this structure. Well, the first thing I'm going to do is I'm going to declare myself a variable, struct employee, and I'm going to call my variable emp1, semicolon. Okay, and now I can do this. I can say emp1.age equals 34. Okay, well that was easy enough. Let's see whether I can print out that information. The age is %d, new line. And now I need to get that same information back again, and I do it exactly the same way, emp1.age. Now let's compile that and see if it works. So compile, and no errors, and run. Should get very simple output. The age is 34. Correct. Now we can make our program a little more complex. I'll create a second employee structure, call it emp2, and I'll say emp2 equals emp1. So now I should be able to determine the age in emp2 as well. So I'll simply say the second age is blah blah blah. Let's compile that and run it, and the second age is 34. So you can see that this assignment statement did in fact work correctly, and that the age that was in emp1 did in fact get successfully copied into emp2. So what about all the other fields of the structure? What happened to the name field and the address field and the salary field from emp1? Did they get copied successfully into emp2? Well, yes, they would have. So what were those values? Well, like any variable, if you don't initialize them, they contain random values. So the fields of the structure that I have not explicitly initialized, in other words, name, address, and salary, are all uninitialized, which means they all contain random values. So those random values would have been copied into emp2. So you can see that apart from the use of this little dot operator here and requiring to specify the field name if you ever want to access the various elements of the fields, structures are used like any other variable. So now, to go back to our CD example that I was talking about at the beginning of this chapter, if you wanted now to create an output function for a CD, what you would probably do is define a structure called CD that contains the artist, the title, the album single, the price, and so on. And the output function would then become quite simple. You would only have to pass it one parameter, and that parameter would be the CD that you wish it to create output for. We'll look at that again towards the end of this chapter.